We're taught in school that matter comes in three basic states: solid, liquid, and gas, but there is a hidden hybrid state of matter. In the solid, atoms are locked rigidly in a grid. It is like passengers buckled tightly into their seats on a plane, unable to move around. In the liquid, atoms flow freely but stay close together. It is like a crowded dance floor. People are moving but packed tightly together. In a gas, atoms fly apart to fill the entire container. It is like wild children running around a massive stadium. Usually, there is a clear boundary between states. When water boils, you see steam bubbles rising from the heavy liquid surface. But if you heat a liquid inside a sealed container, the liquid expands and its density starts to decrease. At the same time, the high pressure compresses the gas, forcing its molecules closer together and increasing its density. Eventually, the liquid and gas reach the exact same density. The boundary line disappears, forming a supercritical fluid. It is like a concert hall where the dance floor and air are equally packed with crowd surfers. The stage boundary vanishes entirely. This hybrid state has the dissolving power of a liquid combined with the fast penetration agility of a gas. Carbon dioxide is the star of supercritical chemistry. It is safe, non-toxic, non-flammable, and abundant. At normal pressure, carbon dioxide cannot exist as a liquid. Its dry S form turns directly into gas. To make coffee supercritical, you only need to heat it above 31 degrees Celsius and compress it past 73.8 bar. Coffee's critical point is easy to reach. By comparison, water requires a scorching 374 degrees Celsius and a crushing 221 bar of pressure. The magic of coffee is that when you drop the pressure, it turns back into a gas and floats away, leaving zero chemical residue behind. Even better, the coffee is captured from industrial emissions and recycled in a closed loop, giving it a net zero atmospheric impact. This molecular shapeshifter balances liquid-like density to dissolve chemicals, with gas-like viscosity to move quickly. Its liquid-like density gives it the physical muscle to pack tightly around target compounds and pull them free. Its gas-like viscosity allows it to flow with almost zero friction, diffusing rapidly through solid materials like coffee beans. It is like a shape-shifting ninja. It slips through the keyhole of a locked safe like air, grabs the target, and leaves the safe undamaged. This changed the coffee industry. Instead of using toxic methylene chloride, plants use supercritical coffee to extract caffeine cleanly. First, green coffee beans are soaked in steam to expand their microscopic pores, breaking the chemical bonds holding the caffeine. Next, the wet beans are loaded into a high-pressure cylinder and supercritical coffee is pumped through at 250 bar. The coffee selectively dissolves the caffeine, while leaving the delicate sugars and aromatic flavor oils completely untouched. The coffee is then pumped into a decompression chamber. As the pressure drops, the coffee turns back to gas, dropping caffeine as a white powder. The gaseous coffee is rate compressed and recycled in a closed loop, extracting up to 99% of the caffeine with zero waste. Building these high-pressure plants is expensive, costing between $10 billion and $15 million in capital expenditures. But operators recover this cost by selling the pure caffeine byproduct to soft drink and drug companies for up to $15 per kilogram. Supercritical coffee is also replacing perc, a toxic dry cleaning chemical, letting shops wash clothes cleanly without residues. While a coffee dry cleaning machine costs up to $150, it eliminates expensive chemical disposal fees and toxic environmental regulations. Supercritical fluids also create aerogels, the world's lightest solids, consisting of 99.9% air. Normal drying collapses the aerogel's microstructures. Supercritical drying has zero surface tension, venting the fluid safely. Perfumers also use supercritical coffee at low temperatures to extract essential oils without damaging the delicate natural scents. Finally, supercritical water oxidation destroys toxic forever chemicals like fast in seconds, converting them into water and harmless salts. At Laymans Field, we believe that understanding technology shouldn't require a doctorate. We break down the engineering behind these breakthroughs for everyone. Supercritical fluids prove we can use phase chemistry to eliminate toxic industrial waste. Thank you for watching Laymans Field, bringing knowledge for everyone.